Hi, everyone. I hope you guys are doing well. I am going to go over this Euler's method problem for you so that you can see exactly what's happening. We're given that dy dx, a differential equation, is equal to x plus y, that y of 0 is 2, and we want to approximate y of 4 with a step size of delta x equal 1. I chose delta x equals 1 because it just makes these calculations a little bit easier. Um, uh, um, Usually you have a smaller delta x. So what do? Well, we've got my differential equation right here. My delta x is 1. I like to identify that. That y of 0 is 2, and I want to approximate y of 4. So I take this 0 right here, and it goes in here. And then because that's the x value, and the y value that corresponds with that is 2. Then in this next column here, I do a calculation for the slope at that point. Well, I know the slope is x plus y, so I take the 0 plus the 2, and that gives me a slope of 2. Pretty simple. Then I go to the next line. So I'm going to kind of hold that in the back of my pocket for a moment, or in my back pocket for a moment. So then I go and I delta by 1 on the x's, right? So I move over 1 positively on my x's. Takes me to 1. I add 1 to this. And then I calculate the y value, or I approximate the y value using this slope. It's kind of like having a tangent line. I take, okay, I paused that for a moment and added a couple things to this document. So I said it's kind of like a tangent line right here. And this right here is the tangent line. What I mean by that is you think of a tangent line, y minus y1 equals m times x minus x1. Well, the y1 is 2. That's this 2 right here, right? The m is 2. That's this slope. And the x1, or sorry, the x minus x1 is my delta x. And that is 1 in this case. So I get 2, that's the y value, plus 2, that's the m, the slope, right here, times 1, the delta x, and that gives me 4. So from there, I then do, like that's my y value, 4, at x equals 1, or my approximation. So what do I do from there? I repeat that process. I now find dy dx again. What do? I do my x value 1 plus my y value 4. It gives me 5. Then I hold that for a moment. I add my delta x to this. That takes me from 1 to 2. What's my y value? Well, it's my new m, which in this case would be, there, I changed it. It's not an m, so it's my 4, which is my y value, right? My new m, which is 5. Where did I get that? From here. Okay. And and then my delta x, which is again 1. So I do 4 plus 5 times 1. That's 9. That gives me my new y value. I want to get a slope. So I find the slope. That is x plus y from this equation here. So I do x plus y. That gives me 11. Take the 11, bring it down here. Add 1 to my x. It's 3. I do 9, the y value, plus 11, the slope, times the delta x1. That gives me 20. Now I repeat, dy dx, x plus y, so it's 3 plus 20. It's 23. That becomes my slope down here. Add 1 to the 3, it's 4. I do 20, the old y value, plus 23, the slope, times 1, the delta x, and that gives me 43. At that point, I was asked to approximate y of 4, so I now have that's y when x is 4. So this is my approximation. Hopefully that helps make a little bit of sense of that. And I'm going to make a video for, I think, maybe B and one of those AP ones.